Assalamualaikum warahmatullahi wabarakatuh and a very good morning. In this video, we are going to learn on how to graph sketching of polar equation. So the method to sketch the polar coordinates is similar to the Cartesian coordinate. So in polar coordinates, the point r theta is marked on the radial, which is 0 to 2 pi in radians, or we can use 0 degree to 360 in degrees from the polar axis with distance r from the pole origin. Okay, for example here we want to sketch the graph of r equals to 1 plus cos theta. So first of all, what we need to do is we construct the table. Okay, we list down all the theta that we want to count in. Okay, so for example here we want to start with 0, 30 degrees, 60 degrees, 90 degrees, 120, 150, 180 up until 360. So the more degree you have here, and it will be the more accurate because we have more points to sketch the graph. So now we just substitute the theta equals to 0 up until 360 into the equation of r. So what we have here is the value of r. Okay, so for when cos theta, when theta is equals to 0, we have the value of r, which is 2. When theta is equals to 30, r is equals to 1.87, 60 is 1.5, and so on. Okay, then from this we can construct or we can sketch the graph. So now let us define the line here. So here is 0 degree, here is at 30 degree. So I want to plot for each 30 degrees. 180. Up until 330 degrees, or this is also can be written as 360 degrees. So using all the values from the table, now we sketch the graph. So from the table, here we have r is equals to 2 when theta is equals to 0. So let's assume that r equals to 2 is here. Then 30 is shorter. At 30 degrees it is shorter, 1.87, 60, 1.5, 1, 0.5, 0.13, and the last one is at 180, it is 0. Okay, next at 210 it is 0.13, which is the same as at 150 degrees, so the line should be the same. And at 240 it is 0.5. And then for 270 it is 1, 300 is 1.5, 1.87, and the last one is 2. So if we try to plot this, you will get something like a heart shape, okay, where this is a cardioid. So you can make this properly. Okay, so if we try to use a software, so suppose the shape should be like this, okay, which is also the same as the previous slide. Okay, in the previous example, you can see here where this graph has symmetrical properties, where this graph symmetry to this at x-axis. So it's like a mirror here. Okay, so we can do the symmetrical test to avoid doing repeated calculations. So we want to check whether the function is symmetrical to x-axis, y-axis, or to the pole. So how to do that is, for the first one, checking the symmetry about x-axis or polar axis. If we have r theta satisfy the equation, so does r negative theta or negative r pi minus theta. And then the second one is to check the symmetry about y-axis or line theta equals to pi over 2, where this refers to this line. So if r theta satisfy the equation, so does r pi minus theta or negative r negative theta. So these are the equation, or these are the conditions that are used to check the symmetry about y-axis or line theta equals to pi over 2. And the last one is to check the symmetry about the pole or at 0, 0. So how to check the symmetry about the pole or origin? If r theta satisfy the equation, so does r pi plus theta or negative r theta. So note that to test the symmetries, we need only to test either one of the condition. Okay, for example, we want to test the symmetrical condition about x-axis. So we need to test whether r negative theta or negative r pi minus theta is satisfied. Meaning that we just choose one. Okay, so if either one of the conditions is not satisfied, we need not to test the other one. So let's say it does not satisfy the equation for r negative theta, you don't have to compute for negative r pi minus theta in order to check the symmetrical about x-axis. Then the last one is that it is possible for a polar equation to fail a test and still exhibit that type of symmetry when you finish graphing the function over a full period. Meaning that, for example, you want to check the symmetry about y-axis and you use this r pi minus theta, and you can see that this function, this equation does not satisfy the original equation. But once you do the plotting, you can see that there is a symmetry at y-axis. So it is possible to happen to it's possible that happen. Okay, now let's try constructing this r equals to 1 plus cos theta. Okay, here you already know that the shape of this. Okay, this is from the previous example. So what we can do is, first of all, before you plot this, you have to find the symmetrical condition of this function r equals to 1 plus cos theta. So first of all, let's try this about x-axis or polar axis. So we check this r negative theta. So we just use one condition. So for x-axis, I'm using r negative theta. So what we can do is just that we substitute r with r into the function and theta with negative theta. So this is the original equation, where here r equals to, so since we're still using r, so we just write down as r. And then 1 plus cos, where theta is now, we use negative theta. So if you try for cos negative theta, if you put any value of theta, let's say negative 50, you can see that the value of cos negative 50 is equals to cos 50, which means that cos negative theta will always be cos theta. So here it will be 1 plus cos theta, where this r equals to 1 plus cos theta is the same as the original function, which is equals to f theta. We also denote this as f theta. So since it has the same value as the function f theta, then we can say that the graph is symmetrical about x-axis. Okay, next is to check the symmetrical condition about y-axis or line theta equals to pi over 2. So for this symmetrical about y-axis, we use r pi minus theta. So here, we just substitute r with r equals to 1 plus cos, where our theta is pi minus theta. Then you can see here, using the identities, trigonometric identities, we can refer to the list of the formula, where this one would be cos pi cos theta plus sin pi sin theta. So cos pi and sin pi consist value, where cos pi is equals to -1 and sin pi is equals to 0. So here would be equals to 0, and this one would be equals to 1 minus 1 times with cos theta. It would be 1 minus cos theta. So you can see r equals to 1 minus cos theta is not the same as the original function. So it means that it is not equals to f theta. Since it is not equals to the original equation, we can say that the graph is not symmetrical about y-axis. Okay, now the last one is to check the symmetrical about the pole or 0, 0. So here, what we use is negative r theta. So substitute r with negative r equals to 1 plus cos, and we use theta, so it's just remain the same. So we bring this negative to the right hand side, it will becomes r equals to -1 minus cos theta. So you can see this function is not equals to the original function, which is 1 plus cos theta. It's not the same. 1 plus cos theta is not the same as -1 minus cos theta. So we can conclude that this graph is not symmetrical about the pole. So here, from this symmetrical test, the graph is only symmetrical about x-axis. So meaning that if we try to plot this, since it is symmetrical about x-axis, so you just have to find the graph or the theta that is from 0 up to 180. Once you get the shape, then you just have to find the symmetrical of the shape for this graph. Okay, so meaning that you just have to construct the table from 0 degree, 30 degrees, 60 degrees, 90 up until 180 degrees. Okay, for example this one. Okay, and get the value of r. So you just have to plot this from 0 up to 180. Then since it is symmetrical at x-axis, meaning that this is the mirror, so the object for this, the image of the object would be this one. So you save a lot of time, okay, without having to find the value from 180 to 360. Now I want you to try out this exercise. Sketch the graph of r equals to 2 plus 3 sin theta. So previously, where you learned about the Cartesian equations, okay, in your matriculation or high school or foundation, okay, you can determine the shape of the equation based on the standard equation. For example, here x square plus y square equals to a square, where the center for this equation is at 0, 0, or if the center is at a point x naught y naught, the equation will becomes x minus x naught square plus y minus y naught square equals to a square. So this equation refers to circle. Same goes with this one, where this equation refers to ellipse, and then for this equation it refers to hyperbola. And the last one, if the equation is like y square equals to 4ax or x square equals to 4ay, it is in terms of parabolic shape. So it depends on the value, whether it is positive or negative, so the shape would be different. Okay, whether it is open to the right, open to the left, and so on. So you can try out to recap all this, but our main focus is for the polar curve. Okay, so this polar curve refers, the equation itself refers to a certain shape. For example, here we have r equals to a plus minus b cos theta, and also r equals to a plus minus b sin theta. So this equation refers to limicons. Okay, but in limicons it depends on the value of a and b. Okay, for example, if a over b is less than 1, it means that it is a limicon with inner loop. Okay, where we have here inner loop in this shape. Okay, but if the a over b is between 1 and 2, it is a dimple limicon. Okay, it's not an exact circle, but it has a dimple here. Okay, and if a over b is greater than or equals to 2, it is a convex limicon. But you can see it is not an exact circle. Okay, so that is for limicons. However, for the special case a over b equals to 1, okay, you can see that this is not called as limicons. Okay, it is called as cardioid. So this shape is depending on the value of a and b. If the value a and b are the same, it means that the shape is cardioid. And you can see also whether the cos theta, okay, for the equation of cos theta, here you can see that the shape is on the right side. Okay, but for a plus b sin theta, it will shown in this y-axis. Okay, for cos theta it is on the x-axis. Meanwhile, for sin theta it is on the y-axis. Okay, this is for limicons. Okay, so then the next one, if the equation is in terms of r equals to a cos n theta or r equals to a sin n theta. So for n theta, n at theta here, it refers to the petals. Okay, so if n is odd, it refers to the n petals would be equals to the petals, the number of petals is equals to n. But if n is even, meaning that for example we have cos 4 theta, so the number of petals would be 2n. So here, for example, cos 4 theta, so it will be 8 petals. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and the value of n must be greater than equals to 2. So these are the rose curve. And the cos n theta, the shape of cos n theta would be different with sin n theta. Okay, and a refers to the length of the petals. So the next one is on the circles and lemniscates. Here we have r equals to a cos theta, where the shape of this equation is circle. Okay, a refers to the diameter of the circle. Okay, and cos theta, you can see it is on the x-axis. Okay, meanwhile for r equals to a sin theta, it is on the y-axis, and you can see a is the diameter. Okay, another shape of the polar curves is lemniscate. So here the equation is r square equals to a square sine 2 theta, and the other one is r square equals to a square cos 2 theta. So at least if you know the equation, the general equation of and the shape of the equation, it's easier for you, especially when you have to plot the graph of the equation. Sometimes when you try to connect the dot, you don't get to know how is actually the shape of the equation. Okay, so if you remember this, at least you know, okay, for example, we have these types of equation. R equals to 2 cos 2 theta. So the shape of the graph should be like this, where we have 2 theta means that it have 4 petals, because it is n is even, so the number of petals should be 2 times 2. So we will have 4 petals, and a should be equals to the length of the petals. So you can refer to the PDF that I provide in the e-learning. Okay, please refer there, okay, and try out by yourself. Okay, the last topic for this is the intersection of curve in polar coordinates. Okay, as in Cartesian coordinates, the points of intersection are the common point of the two curves. Okay, for example, we have a question of x square plus y square. This one is refers to a is equals to x square plus y square, and we have another shape which is a equals to x. So here we have a circle, and also we have a line. So we want to find the point of intersection for this, where we just have to solve this simultaneously, where it will be x square plus y square equals to x. So solving this, you will get the point of intersection. Okay, so same goes for the polar coordinates. So to find the points of intersection in polar coordinates, you will get the points of intersection by solving the polar equation simultaneously. So let's try this example. Find the points of intersection between the circle r equals to 1 and the cardioid r equals to 1 plus cos theta. So here, this cardioid, you can try to sketch this, where why is it cardioid? Because you can see for the general equation, r equals to a plus b cos theta. So here our a is equals to 1 and b is equals to 1. So a over b would be equals to 1. So that is why it is cardioid. So since the equation is cos theta, meaning that the graph is on the x-axis. So it would be something like this. Okay, and then we have this circle r equals to 1, meaning that for every angle, the radius is equals to 1. So start from 0 degree up until 360. So you can see that r is equals to 1. So from here, you can see the point of intersection. There will be 2, which is here and this part. So now, how to solve this is that we will solve this using what we need to do is we have to eliminate this r. So it will become 1 plus cos theta, where 1 plus cos theta is equals to 1, because r is also equals to 1. So what we can do is cos theta equals to 0. So theta would be equals to 90 degrees. Okay, but here if we try to plot cos theta, so the value of 0 is at 90 and also 270 degrees, meaning that for this value of theta it will be 90 and also 270 degrees. This graph refers to cos x. Okay, when theta is equals to cos theta equals to 0 is when this value is 90 degree and 270 degree. So that's why the value of theta is these two. Okay, now we have obtained the value of theta. What we want to do next is we want to determine what is the value of r. So for theta is equals to 90, r would be equals to 1 plus cos 90, which is 0. So here is 0 is equals to 1. Same goes when theta is equals to 270, r would be equals to 1. Okay, so the points of intersection between these two shapes would be 1 90 degree and 1 270 degrees. So sketching the graph would help you to determine how many points of intersection are there. So that's why you need to know the general shape of the equation. Okay, and also you can plot this, okay, using theta equals to 0 up until 360. Or before that, you can test the symmetrical test to determine where the graph symmetrical to. Okay, now you can try out this example. Find the point of intersection between r equals to 3 sine theta and r equals to 1 plus sine theta. You can pause the video and get the answer after this. So first of all, let us determine. So here r equals to 3 sine theta. So 3 sine theta refers to the circle. Okay, where since it is sine theta, it means that it is on the y-axis. So it will be like this, where r is the diameter of the circle. So it will be 3. Okay, and then r equals to 1 plus sine theta, which is this one refers to the cardioid. So a cardioid sine theta, it is something like this. So to determine what is the value at theta equals to 90, because we want to know whether that this cardioid, is it intersect or not with the r equals to 3 sine theta at theta equals to 90. So we just substitute the value r equals to 1 plus sine 90, where here is equals to 1 plus 1 equals to 2. So this one is not intersect. So the point of intersection, there will be 3. The first one is here, here and here. Okay, now let's remove the r, where we get 3 sine theta is equals to 1 plus sine theta. And then here we have 2 sine theta is equals to 1 sine theta is equals to half, and we get our theta, which is equals to 30 degrees. So for the sine value, since it is positive, so we can know that it is also for the quadrant here as S. Okay, So this one would be for 30 degrees and the other one would be at 180 minus 30 degrees, which is 150 degrees. So the other theta would be equals to 0. Why? Because for it refers to this point. Okay, so now we have complete all the theta. The first one is at 0, the second one is at 30 degrees, and the third one is at 150 degrees. So now is finding the value of r, where r is equals to, for theta equals to 30 degrees, your r would be equals to 3 sine 30 degrees, which is 3 over 2. And when theta is equals to 150, this one would be also 3 over 2. And when theta is equals to 0, your r would be equals to 3 sine 0, which is equals to 0. So the point of intersection would be 3 over 2 30 degrees, 3 over 2 150 degrees, and the last one is 0 degrees.